Okay, so I think the introduction was put on the Facebook, but I can quickly introduce myself. I'm Jeff Radom. I currently work as a test engineer at Oracle. Before that, I just doing this for about 9 years. Before that, I was a developer for a long time, and I was involved in manual testing, in automation processes, etc. And again, you can read my profile. I mean, not the full one on the LinkedIn, and I think it's also attached to that invitation. So what I'm supposed just to deliver, it's like the ways some leading companies here in the US um, use their below methodology. It doesn't mean that everyone have used it, and I will tell about this later, but it's just observation. And then it's up to every person to make a decision whether to use it or not, whether the company decide to use it or not. Okay, this is, if nobody ever seen it, there's several permutations, so-called testing pyramid. If you'll see, by the way, can you guys hear me okay?
Yeah, we can.
Yeah.
Do I speak very quickly or it's okay with you? Again, I mentioned that I think Blanca knows English not the first language for me, but I speak English for the last 30 years. So, but anyway, so is it okay? You can understand what I'm talking about?
Yes.
Okay, all right. Okay, just tell me. Okay, again, so this is so-called testing pyramid. If you look, there's at the top a little piece called manual testing. In the bottom, it's primarily, focused on automation. It's automation GUI tests, and then it's like slide percent. Then the middle tier, it could be different in different companies, but it's consists of like integration testing, and then in the bottom the unit tests. The most important part is the unit test. I also want to mention that that methodology I just will tell you, the more responsibility I put on the shoulders of developers. For one main reason, because developers are the ones, if a test engineer or QA engineer just find an issue, it goes back to developer anyways. Because usually the test engineers or QA engineers, they don't fix the problems, they discover the issues. And again, Google is not something you have to be paranoid about. It's one of the leading companies in the world which deliver software that's used by billions of people. I bet you guys use Google all the time, or Yahoo, or whatever. I use it all the time. We need to find a code snippet or some kind of other things. And it's also works in different languages. I think they support like 120 languages in their search engine. So Spanish for sure is there. Spanish, English, German, you name it, French. So how Google does this test software. And I just, by the way, I think Blanca distributed, whoever wanted to download that document, you can read this later. So, and the main thing is here, if you are an engineer, I hear some noise in the background. Some kids, hello?
Hello. If somebody have opened the microphone, if you can put everybody in mute your microphone.
Because some kids are screaming in the background, I think, or playing some kind of games. Okay, anyways.
Wait, I will mute everybody. Okay, now you continue. Yeah.
Maybe they were your kids. Okay, no blame. Okay, so if you are a test engineer with a road, by the way, a lot of companies eliminated the title QA engineer, just call these people test engineers of different levels. In your title, then you are enabler of good testing for those other engineers who do not have this title. And I don't know if you guys read this book. I read this a few years ago. The whole thing is based on the best-selling book, which has a name, How Google Tests the Software, of these authors, James Whittaker, James Arbon, and Jeff Carolla. All of them work for Google at different times for different, as a high development managers. And the methodology will describe is used now at companies like Google, Yahoo, Facebook, Twitter, Intuit, LinkedIn, Microsoft, etc., Amazon. And I think you guys heard about all these companies. The methodology becomes de facto industry best practice. It proved to deliver software to different range of customers, which function with the highest possible quality. So, but that doesn't mean one size fits all, meaning it should not necessarily work for any company, small, mid-sized, big, startup, or well-established company. But I think if you guys use Google products, I think everyone used the search, the Google Docs or whatever, it's very rare it shows a bug or something. I think you can agree with me. Okay, so this is the picture how Google does it. By the way, I worked for a different group. I worked there for 2 years. We were acquired, our company was acquired, and we used the more traditional way of testing, like after the fact or whatever. So in Google, in other words, everyone is a tester. They don't segregate testing from the development. Okay, so the main thing from this slide is that the quality can be tested. It's so cliche. But the simple solution to this conundrum is stop treating development and test as a separable disciplines. Quality is not a test. Quality is achieved by putting development and testing into a blender and mixing them until it's indistinguishable from each other. In other words, a lot of companies like to have QA engineers, the ones to blame. If they have an issue, they blame whatever. I was blamed many times myself. Okay, and I think you guys experience the same thing. So, and this is another thing that Google tried to actually to promote. Quality is not equal to test again. Quality is achieved by putting development and testing and blending them together. And at Google, everyone is a tester. And by the way, it's not only automation wise. It's still, you know, some people think, look, if everything automated, what other key engineers will do who don't have a skill to do the automation? It's still, if you remember the testing pyramid, you still need to do the stuff using eyeballs. There's some things you cannot automate. It's like, especially like visual testing. If you talk in different browsers, the look and feel could be slightly different. And there's some tools available, but I need to pay for them, and etc. So another interesting idea, what they use, the quality is more than act of prevention. It's that is detection, and the quality is development issue, not a testing issue. Some people say, look, you ran the test, they failed. Yes, your code can fail, but in the end, if the feature fails somewhere, it's actually not the feature of the test, it's the feature of whoever developed the software in the first place. One more thing, it's very important if you compare a doctor, there's a good doctors and bad doctors. It's the same kind of a paradigm. And if a doctor have a patient, a good doctor will do the tests before somebody needs a surgery. The not so good doctor will never do the test to prevent the illness. He will do it after the fact that the person almost dying or so. But the whole point is, it's much better to prevent the issues than to do the catch-up after that. So now I want to compare, it's very popular paradigm, end-to-end testing. I mean, everyone heard about it. So, and the other part is, at the end-to-end, if you remember, it's at the top of the pyramid. That means it should be not a very high percentage, but the main percentage of the tests are unit tests and integration tests. So here's another slide. You can read it yourself also. So it tells that, the end-to-end tests, they are good. They have some values, but in a lot of cases, like developers like them because they offload most of testing of others. Managers like it because, tests simulate real user scenarios, and they can help to easily determine how the failing test would impact their users. So, testers like it because they often worry about missing a bug or writing a test that not verify the real world behavior. And but here's the other thing is, end-to-end tests by design, they're long. Since they're long, they are brittle and they can fail sometimes randomly. And sometimes they actually hide the real issue. So it actually fails, but there's some other stuff is hidden there. So, and this is a comparison. Okay, I'll just tell you, it's a comparison I think I took from the book, and this is how many days left before the release, and it tells how finally people fix the issue. Now, this is the analysis, and the analysis say that what went well. Customer impacting bugs were identified and fixed before they reached the customer. That's a good part. What went wrong? The team completed their coding milestone a week late. Everyone know that when a test engineer can get some software, in a lot of cases it's late. It could be 1 day late, it could be a week late, sometimes 2-3 weeks late. And then we have a very few time, few days to finish our stuff. And finding the problem in a end-to-end test is sometimes painful because, first of all, they take a long time, whether you do it by hand or you do it automated. And especially if you do it automation, you found a bug, you need to analyze that, and you need to run it again after you fix that. It also takes time. And okay. And the true value of tests, it's kind of a, it's have to be focused on the end user, because in the end of the day, we deliver a product that's supposed to work with the minimum issues. And that's also just shows here. So in general, the failing test, it doesn't have a value added, right? So then the bug opened, okay? And only when the bug is fixed and you verify it, it has an added value to the final product. Okay, so if you talk about the unit tests, there's a few features which make them desirable and to make them as more coverage as possible. Unit tests are fast because they usually done directly on certain small pieces. Unit tests are reliable because again they work with small units, and the flakiness there is very rare. Unit tests isolate failures. If they written in a smart way, they can isolate the regressions or actual bugs in a particular unit. And although like end-to-end tests a better job simulate the users, the advantage quickly become overweighted by all the disadvantages end-to-end feedback loop. And this is the table.
Hi, Jeff. I cannot hear you. Maybe you are on mute. Can you hear me, Jeff? Can you you have mute your microphone?
Okay, so I did. So okay, let me repeat that. Okay, so this is a comparison unit tests versus end-to-end. So the unit tests are fast and end-to-end are slow. The unit tests are reliable and end-to-end are not reliable. Isolate the failures, the unit test can isolate and end-to-end does not. But simulate the real user, that's the reverse. That doesn't mean that you don't need end-to-end. But what I'm saying, it has to be like not to the minimum, very reasonable, low amount of your tests. I'm trying to. Okay. The integration tests. What integration tests do, if you remember it, like it's a middle layer between the end-to-end and the unit test. They actually, they glue together the unit tests from the different units. And it's also supposed to be done by developers, not by test engineers or whatever. So, and then just repeating testing pyramid again. So the testing pyramid, there's several permutations of it. Okay, it's a little bit simplified. So the top is end-to-end, which combines actually the automation and manual. Integration tests, usually it's automated part. And the unit part is also, in most cases, is automated. Ideally, the bottom ones, unit and integration, supposed to be done by developers, maybe in conjunction with the test engineers. End to end, yeah, could be done by test engineers if they have certain skill. Like I said before, the just approximate percentage what Google does, for example, they have like 70, 20, 10. So 70% of the tests are unit tests. And the unit tests, the way they're supposed to be designed, they have to be verified during the review process of the code. So if somebody review the code of some other developer which developed the unit tests, they have to look, they're really smart unit tests, they do something, not just for only numbers. So to achieve the number, it's part of the goal. Also, they have to do real verification in case of delivering a small piece of software and eventual regressions. The other extreme part, so we talked about the pyramid, right? So it could be another like bad way to do it from the old times. It's called inverted pyramid or ice cream cone. That's actually the pyramid upside down. I'm not going to cover the hourglass, but because it's very rarely used, hourglass. So summarizing it. So the ultimate goal of most companies now to do the continuous integration and continuous delivery. So it has to be ultimate goal. But what does it mean? That means if you deliver a software with very small pieces, especially agile, so you have like 10 stories in your sprint or whatever, and you deliver each story such a way that it contains the code for functionality and also the code for testing, and also it was tested in addition to this at the top, like manually. Then, but it's not, again, one size fit all. There could be some legal implications that don't allow easily to deliver this to the public. Like if you talk about if somebody deal with HR applications, sometimes you need to verify many times, because if you expose some information, like in the United States as an example, if you expose the name of the person in some kind of analysis, it could be different law violations because of the privacy issues. And each country is different. These are some conclusions. Based on the previous part of the presentation. And I will read this. So some people say, look, if developers do the major part of the testing, what test engineer will do? So the answer is the test engineers, including the managers, doesn't need to be scared. It's still a lot of stuff to do, because the software, by definition, when you deliver it, a large piece of software or small, it will have some bugs no matter what. It's a big company, small company, Microsoft or Google, it still have the issues. The goal is try to prevent them and to make them as minimum as possible. So for example, if you talk about, by the way, I put some stuff here related to Agile. As a matter of fact, Google doesn't recognize Agile as a good practice. So most companies like Oracle, the others, they think that Agile is a modern way to deliver software in a small iterations. So, and if you talk about the Agile development, I put like a point one, we should define the minimum threshold, let's say 85% plus unit test coverage, when code can given to the review and all passed. We should use the tools available to certain language, and we watch this out. So at Google, for example, they support 3 main languages as for development. They support C, Python, and they support Java. For each tool, they have the way. Let's say if I developed a piece of software and I want to pose this for the review, if I have less than certain threshold, let's say 85% or 80 or 75, over a unit test coverage, I can't even submit for the review. And there are tools available for different languages. If we talk about the test engineers who has the skills to do some programming, the main goal at Google, these test engineers, they don't develop the software to test a particular feature. They develop the set of tools that make developers test that features themselves. In other words, they develop the tooling that make the life of developers easier when they test their own developed software. And if these common components require the changing, then they go back to test engineers and they make the changes. If we talk about agile and we talk about the sprints, each story of a sprint, usually when I worked previously for some other companies, is considered to be done by a developer when all unit tests are developed and passed and with certain coverage. Integration and functional tests, including UI and non-UI, are developed and passed, primarily by developers, but like I said, developers use the tools of the test engineers developed for them. And other thing is very important thing, if you test a software like manually, whatever you have the test cases or